Welcome to 10x Engineering. This talk is presented by Urban Company, Asia's largest platform for home services.
Okay, so myself Jatin, I've been part of UC for close to 5 years now, and I've been looking after a lot of infrastructure and security related things. As Kushal already mentioned, I'll be talking about our journey to achieve 100% PII encryption to secure all the personal identifiable information for our customers, for our partners. Right. So to set the agenda, we'll discuss what exactly is PII. What exactly is PII? Why should you encrypt it? Why should we encrypt it? And different stages as of this journey. Like first you have to detect the PII, then structure it, and then maybe encrypt it. Then we'll talk about the design of our platform of our encryption framework and what choices did we took. And lastly, few enhancements which we'll cover. Correct. So what is PII? Simply mentioned, PII is nothing but a piece of information which you can use to track back to a particular individual. Right? Using a phone number or using an address, you can directly pinpoint to which customer's data this is and maybe provide harm. So this itself shows that how much important it is to encrypt the PII and prevent it from leaking. So before we get into the technical governance and compliances, you would not want your PII to be leaked. You would not want your address to be publicly available over the internet. So that is the main reason which you want to encrypt. And speaking of some regulatory requirements, the GDPR, DPDP compliance, which asks us to protect the customer's data. Second would be fines and settlement in case of the data breach, and exactly loss of brand and value is there. Right. So now we have set the context of what is PII and why we need to encrypt the PII. Before that, we can talk about few data breaches which recently happened. Right. Bank of America, around 50,000 individuals' customer data was leaked and they were contacted by some attackers. Similar thing happened with McLaren Healthcare. So yeah, very important, very much important to encrypt the PII. This is our journey. These are the multiple stages which we'll talk about. First is detection, then the structuring of that data, and then finally encryption. So detection, let's talk about detection. Before we go on this journey of encrypting the PII, it's first important to know where all the PII is stored. At UC, I mean, all of you are working in the companies and you must have databases, you store the information of your customers. So at UC, we manage approximately 150 microservices, and those store the data across 20 MongoDB clusters, multiple MySQL and Elasticsearch clusters. This data is a mix of bookings, orders, customers data, partner data, and yeah, so first let's centralize, let's pinpoint where the PII is stored and then move on from there. So we have divided it into 3 stages. To detect the PII data, you first have to scan your databases, right? Because the data is present in the databases. So the first step would be to, which will cover majority of the database portion, is to just scan your schemas, check the schema of the database of your tables, and identify the keywords like if phone is present in the column name or address is present in the column or the Aadhaar number is present in the column name. Right, you can define a set of potential PII keywords and match it against it. So first step would be to scan all your databases, check for potential PII keywords, identify the data. But this will cover majority of your data, but still there are few places where data will remain. Let me give you an example. There can be some data which does not necessarily falls inside the fixed field name. For example, this update history. Whenever a user updates his settings on the profile, so you can store this string like user A has updated the number from this to this. So this is also a potential PII candidate, but will not be cached if you run the checks against the schema fields. Similarly, this does not necessarily means every field of the update history will contain PII. So what's it important is to select random documents, select random 100 to 100 documents from each of your table, each of your collection, and run regular expression checks, from which you can detect that, okay, this is the my regex check for phone number. If it's present in the data, alert it. This will also cover rest of your portion, but one more thing which we encountered was we found some data which does not match any regular expression checks, which was mainly address. Right, address does not match. You cannot create a regex for address. So what we used is we used LLM to detect what if there is a potential address in the collection or not. After this activity, we were able to identify around 100 tables which were containing PII, which is a lot, and these tables were managed by multiple microservices. Each were managing its own set of data. It may be redundant, it may be not needed, but yes, this was the initial state before proceeding with the encryption activity. So now we have detected the data. Next step would be how to structure it. Before encryption, let's take a call on what we want to do with this data. So yeah, again, very important to structure. First approach of structuring would be to let the data as it is, keep the data as it is, let it be in decentralized form, and encrypt it wherever it is present. So it's the most quickest approach, right? It requires very less effort. You just you've already detected the table names, go inside it, encrypt it, and it also causes no changes in the flow of the APIs. You don't have to do any code changes. The second, a better approach in terms of security is centralization. You analyze that data, you centralize all the PII to a fewer stores, fewer databases. Instead of maintaining 100 tables, you can use 50 or 10 to 20 tables and centralize PII to that particular field. This enhances the security, this limits the encryption radius, this reduces the exposure. Now you have to manage only single 2 or 3 database clusters which are containing the PII. Right, and of course it helps deprecate very redundant collections, because earlier we found out that same data was stored by multiple microservices. But this comes with the challenge of that initially services were storing the data locally with their in their data store, but now they have to call some additional service to get that PII data. Right, so what we went on with centralization, we created dedicated entity level PII stores. What I mean by entity is every set of users which we have, which is there can be customer related data, there can be partner related data, there can be employee related data. So yeah, we created entity level PII stores and separate microservices which will just manage these databases. No other microservice will connect to this database. Right, and for a few special entities like trainers, orders, etc., which are somewhat decentralized, so we created specialized 2 or 3 services for it. After this activity, we were able to reduce our PII tables from 100 to 10, and then also reduce our PII managing services from 20 to 5. Yeah, now we have structured it, we have detected, we have structured. Now the next step would be to actually encrypt that data, which is the most important part of this talk. Okay, let's discuss the options of how to encrypt that data. First, you've all worked on cloud, you all manage the cloud, right? So there's a very simple operation on how to do this, is what AWS, what Azure and Google also provides. Simple storage level encryption. What it does is it encrypts the storage at hardware level and using KMS or whatever key vault in Azure, and keeps the data in the encrypted form at the hardware level. But if you gain that database access, you gain that shell access, or you go on to that machine and access that database, you will get the data in the plain text. So does not make sense. This complies with the few industry standards, GDPR, etc., some compliances, except this, but this is not secure. Right. Better approach would be to encrypt at the column level. Right. Encrypt actual data stored in the specific columns. This helps to target the encryption fields. You do not have to encrypt all of the data. You just have to encrypt the PII fields like address, phone in the user details, for example. Right. And first we have encrypting, then we are inserting. We are not relying on the database itself to encrypt it after storing. Right, and most importantly, security advantage, if any attacker gets to that database, he'll not be able to make sense of that data. Right, so here we are selecting now column level encryption, we have discarded AWS level encryption, and okay, so now to encrypt, we need some method, right? We need some mechanism as on how to encrypt it. So let's talk a little about 2 or 3 encryption methodologies. First is symmetric encryption. Okay, so to encrypt, you need a key, right? This will be the plain text data. You will need a key. With that key, you will encrypt that data and store it with your database, and that key you'll have to protect. Right, so symmetric encryption, what it says is use the same key for both encryption and decryption. So you take data, you encrypt it with the same key, store the database. While fetching, you fetch that data, decrypt it with the same key, and then pass on to the customer. This is a lesser secure approach, but it works very better for private communication, where your data is not flowing over the internet, it is privately communicating between your multiple machines. And you've already restricted security group rules to allow it. Right. The second is asymmetric encryption, where there are different type of keys. One public key is used for encryption, and then private key is used for decryption. So it is very suitable when people are sending the messages over the internet, so that if your one key leaks, the attacker cannot make sense of your data. Your both keys have to be lost. But it takes, of course, longer time because there are 2 keys involved. There is a hybrid type of approach, envelope encryption, which let's understand it in detail. Here data is encrypted with a particular key, okay, and that key is also then again encrypted with a separate master key. So this is the data, this is your key, encrypt your data with this key, and then again encrypt this key with master key and store it separately. Even if your data key gets lost, since it is encrypted, no one will be able to make the sense of the data. What we went ahead with envelope encryption, but we'll use one key for both encryption and decryption. I hope envelope encryption is clear, but I'll still explain it again on diagram. So there are three steps for envelope encryption. First, you'll have to generate the encryption keys, right? Before encrypting the data, you first need what the master key and what the data key is. So there are multiple solutions available. You can use any key manager service provided by AWS or open source as well. You create master key, you create encrypted data keys. This is your initial set of keys which will be used for further encrypting the data. Then you will store these encrypted data keys in your secure database, because these keys will be used in the future, right? Master key will be managed by manager service, key manager service, but encrypted data keys will be stored at your end. Now, before encrypting, you need to fetch that key, right? Let's say customer API was called to profile service that add this data into DB. So customer profile service will first need to encrypt that data. So to encrypt that data, it needs to know the key, which key it should encrypt with. So it will, from that secure data store, customer profile will maybe fetch encrypted data key, because in the data store we are keeping the data key as encrypted format. Then we'll pass that data key, encrypted data key, to KMS to get the plain text data key, right? As I told you in the envelope encryption process. Once the plain text data key is with us, now we'll use that data key to encrypt that data using some process and create the encrypted data. Okay, so these are the basically three stages of how envelope encryption works. Again repeating, you need a key manager service to master your master key and data keys. Then you need to store those data keys somewhere in the encrypted format, and then you need to fetch the keys, decrypt it, and then encrypt your data. Alright, so now we are clear with the envelope encryption design. Let's design an encryption decryption platform which we are using. So what all components do we use before designing? So again, first we need to know how do we generate master and data keys, as I already mentioned. Then we should know where the data keys should be stored, which was the secure data store. Then we should know which data key should be used for encrypting what type of data, because you may have multiple options. You can create a single data key, encrypt all of the data with it, or you may create multiple data keys for a particular set of data, or you may create single key for each user. So that depends on what your use case is. And then lastly, actually encrypting that data. Now you have the key, you have the plain text data encrypted, right? So this one, let's discuss about the key manager service one. So there are multiple solutions. If we categorize into two parts, you have a managed solution and you have a self-hosted solution. Managed solution provided by AWS, Azure, GCP, etc. The advantages are fairly simple. It's very simple to manage. It's very easy to generate and rotate the data keys. Also, you don't have to worry about the scalability, as it provides HA out of the box, right? But the cons of this approach would be the keys are stored outside the organization. You do not have control over your master keys. So if AWS or if Google Cloud leaks your keys, your data can be compromised. And dependency, of course, on a single cloud platform. If you self-host your key manager service, keys will anyways be present in your organization, which is a more secure way. But it is a complex, and again, it is a time-consuming initial setup. You have to require maintenances, scalability you'll have to ensure, and multiple other things. So based on your call, based on your company, there are different trade-offs. You can choose any of the following approach, right? So, but keeping the keys safe with cloud is a better solution, in my opinion. Cool. So now once you have generated the data keys, you have to store it somewhere, right? The secure data store. So any storage will do, right? You can use Vault, you can use MongoDB, you can use MySQL, any database with fast lookup capability, so that before encryption you'll have to fastly fetch the key and encrypt the data. We have proceeded with the MySQL database because we are using MySQL extensively, and simply you'll have to just store the keys. Why not keep it in a MySQL database, right? Now the next step would be to find the encrypted data key, like map which key will be used for encrypting which type of data. Again, you have multiple options here. Two of the following can be: you can use one key for a single user, or you can use one key for the entity level, right? One key for a single user would be more secure, of course, because if your one key get leaked, all the other data is safe, right? If your single key get leaks with the attacker, he'll only be able to make sense of a particular row. It offers one more benefit is if you want to delete that customer's data, you have to just delete that key, and you yourself will not be able to make the sense of that. But it's of course very difficult to manage. As users and partners grow, your keys can grow exponentially, and you may face scalability challenges. On the other hand, if one key per entity or one key for all, it's very easier to manage, very less number of keys, right? You can keep the key in memory also for faster lookups. But again, security point, that if the DEK is compromised, if your data encrypted key is compromised, all PII could be at risk, right? But yes, of course, it requires the leak of master key also, right? So we have covered what are the options for key manager service. We have covered the options for secure data store, how to select your data encrypted key, and lastly, once you have the key, you will have encryption process, right? To actually encrypt the data in your microservice, you can again use managed solutions like KMS exposes APIs, Google Cloud exposes APIs. Call that API, provide your key, provide your data, it will return you the encrypted data. It's very simple and easy to set up, but it exponentially increases your cost with higher throughput. And also, one major limitation is they have a limit over payload size. So you cannot, in case of AWS, you cannot send more than 4 KB of the data to cloud. Other option is client-side encryption, right? You do not have to call any API. You encrypt it in your code only using some external libraries or SDKs. Like AWS provides an SDK of encryption SDK and crypto library, which you can use to directly encrypt the code at your end. So this provides you the full control over the encryption decryption process, right? But you have to ensure that your service scales as it encrypts, because encryption decryption is a compute heavy operation, right? So what we went ahead is use crypto library. It is already adopted in the industry. Also, this crypto library itself is being used in AWS encryption SDK. So AWS encryption SDK is also using crypto behind the scenes, and multiple other encryption libraries are using crypto behind the scene. So why not directly use it? Right? This will do not have to pay any cost, and also the PII remains with the organization, so win-win. Let's discuss the final architecture. We have finalized on all the 4 components which were earlier discussed. Right. So this is the current state as of now. Till which we have reached the path. There will be central PII services, which we talked about in structuring of the data. There will be some business services which needs this PII data. So business services will call central PII services. Central PII services will have their own data stores. But let's say there is a call to add user. Someone calls an API of add user. Now customer profile service, before storing it in the database, needs to encrypt that data first, right? Because we have to solve for encryption. So customer profile will call security service, a separate service for encryption, and it will send the data of, it will send entity, which can be user ID or which can be user or whatever you finalize on it, and it will send the data. So now security service, before encrypting it, has to have a key with which it will encrypt, right? So it will fetch the key from the secure data store we talked about based on the entity. Now, because that key is encrypted inside the database, it will have to first get that decrypted from key manager service. In key manager service, again, can anything, you can either self-host or you can use AWS or any other cloud. After the security service has received the plain text data key and the plain text data, now the next step would be to encrypt that data, for which we are using crypto library, right? Crypto.encrypt, send that DK and send the data and return the end output to the central PII service, correct? So this is the flow, which is the final architecture. Now there's a little flaw in this, optimization you can do. Let's say customer profile is having a huge amount of throughput for encryption decryption. So anyway, security service will have this huge throughput transferred. Now, for every encryption decryption call, security service, what it needs a encrypted key. It needs to fetch the encrypted key from the database. And you're not changing your key on entity based, you're not changing your keys regularly, right? So what you can do is, after the security service, instead of fetching the cache, instead of fetching the plain text DK from the DB, you can just cache it in your local memory. And after caching, it will be a very faster lookup. You just call crypto library and return the data. What it prevents is 2 things. First, it will reduce the call to your database, saving time. Second, it will reduce your calls to key manager service. If it's managed solution in your case, it will reduce cost extensively. Huge cost difference if you call KMS at exponential throughput, right? So this is a small optimization which we can do, adding cache, right? So now we have encrypted, now we have created central PI services, we have detected the database, central PI databases, we have created security service for encrypting, decrypting. Now security service becomes a very important service for which you should ensure the security of this service and the infrastructure as well, right? So what we have done is set up this service in a completely isolated environment right? It has restricted access, it has proper auditing. The key manager service, which handles the master keys, is only accessible from this service only. No other service can access this key manager service, which is very important, because if key manager service is accessible by all, you can decrypt your DK. And the last thing, at the client level, any service calling security service has to be whitelisted first and has to provide an authentication token before calling the APIs. This will ensure that no other service except from the central PII services should call for encryption, right? So we have covered detection, we have covered structuring, and we have covered encryption. First we detected PII in the databases, then we structured it, centralized it, and then we encrypted it. All the three designs are completed. One enhancement which I want to talk about is, in this earlier design, you can see security services decrypting the data and passing it to central PII services, right? Now wherever this data is being passed in the request lifecycle, everywhere the data will be flowing in plain text, correct? So what you want to ensure is that only the required service gets the plain text data, else in the request journey, whatever in the network, in the transit, the data should be in encrypted form itself, right? So this is an enhancement which we are targeting. So it's we are calling it decryption at leaf node, right? Where it is required, just decrypt there only, do not decrypt at security service end. So in the current setup, PII services send plain text data to any requesting service, right? This creates insecure data in the transit. If someone gets your network access, he can get the data from the TCP dump or whatever it is, right? Also unnecessary data exposure. You don't need it, so why send it? So let me give you an example. Let's say you have a dashboard, and on that dashboard you want to show list of all users or list of all Urban Clap customers whose membership has expired, UC plus membership has expired. So it calls a gateway service. This service calls subscription service, let's say. This is a random example for getting the expired membership users. Now subscription service calls profile service because it needs user details. So it calls get user details to profile service. Profile service will call the database, fetch the list of users, get that data decrypted because now it's encrypted in the database, right? Now customer profile service will return this plain text data to subscription service. What subscription service only need to do is filter based on the status, filter based on the membership status, right? So it just need to know that whether the membership status is expired or it is active. It does not need this email and phone in plain text format. So yeah, this subscription service passes it to gateway, and the gateway shows to the dashboard. Now the flaw here is subscription service, I already mentioned, is getting exposed to the plain text data which it do not need. So what could be the solve? One is customer profile service returning encrypted data itself, then subscription service also returning encrypted to gateway. Instead of getting that data decrypted in customer profile, get that decrypted in gateway service, because that is the last point of contact from which your data will flow outside UC. So this will prevent internal transfer in encrypted format. To create this or to solve for this, you first have to again detect it. So what we have done is we have implemented a capability which sits in every service. It tracks every call of your system, checks for the request response payload, and detects potential PII using the same framework which we talked in the initial slides, right? Regular expressions, etc., etc. So, and then we plot a graph based on that transaction ID, and we can detect what PII is flowing in which API. This restricts PII decryption to occur only at the gateway level, which of course enhances the security. And one of the more important things is it identifies APIs that may leak PII. So instead of us getting reports from outside world, we can initially identify that these APIs can leak PII. So add better checks and authorizations. To summing up the complete presentation of this framework, what we have built has enhanced user privacy. We have now better control over the PII data which we are storing. Compliance obligations is ticked. We are compliant with GDPR. And also it helps to give us the privilege of accessing user rights, accessing users data and deleting it data based on his request, which is now very simplified as the data resides in central stores. So from one place we have to only delete, and yeah, that is all I think. Thank you.